Hey there, IoTeX community. We have a special interview today with Daniel Zackerson, CEO and co-founder of Scale Out Systems. Hello, Daniel. Please introduce yourself.
Hi. My name is Daniel. I'm the CEO of Scale Out, and as a really short intro to Scale Out, I think Scale Out is a machine learning company, and we work with developing some of the basic tools and methods that you use to do machine learning. And specifically, we've been for the last couple of years focused on different methods to scale privacy preserving machine learning. So a special area for us is something called federated learning, but we can go more into that later. So Scale Out was founded 3 years ago. It's partly a spin-off from one of the universities in Sweden, which is also one of the oldest universities in Northern Europe, Uppsala University. So we have 3 co-founders that are active researchers in distributed computing, but also in bioinformatics. People that I've come to know over quite some time and to be some of the best in this field also. And I mean, we had the seed for Scale Out for quite some time, but also, I mean, there comes a point also in time when you reach sort of an inflection point. There's so much happening in the space that it's hard to keep back, and that's actually what happened. So we had the seed for Scale Out, and I mean, we were considering if we should keep this as a sort of research initiative for some time, or if we should go with it and try to develop the company around it and scale further now and try to scale it out a little bit. And that's what happened in 2018 when we took that decision that, we can see that there's so much happening right now. And I mean, you have traditional tools to do machine learning, but there's also many new tools coming up, and also especially from the start, for me, the potential of integrating some blockchain solutions or Lego bricks, if you like, and solve some specific problems that wasn't really possible to do before. That was one of the drivers for us to go full-hearted into this.
And you guys have kind of experimented at the research sector, but also applying that research into some enterprise efforts, right? You guys are working with some interesting airline machine learning models. I'm not sure how much you can talk about those relationships, but
I mean, one of the most important reasons for that is that we want to keep one foot in the industry to understand how quickly and how ready are enterprises to adopt these kinds of new technologies that we're developing. So that's one side of it. And the way that we structure Scale Out as a company, so almost by design now, we have this one part of the company that is more focused on research and also led by the researchers. And then we have the more product-focused company and the people that are employed in the company. So the way that we've done is that we have a quite clear idea about where we want to go as a company and what we want to develop. And we can call this the Scale Up platform, which is really about bridging traditional machine learning and some blockchain aspects, because we have some things that we want to solve that's not really possible to solve in a traditional setting.
Right.
A lot of that is about being able to collaborate, and especially collaborate around data. Like I said before, having access to data is one of the hardest and also most challenging problems in machine learning. The companies that we're working with now, we can name a few examples, but you mentioned airline. So there's one project, it's together with Swiss Airlines, it's together with one of the big aerotech companies in Europe called SITA, and also Eurocontrol, which is one of the authorities for flight traffic control. And that project is really about making airlines and other airline industry partners collaborate around data sets. So it's the same basic premise here, that and what they're trying to do is creating, we can call it alliances of companies. But when you have a common problem across different companies. So these companies, they don't really trust each other. They are fierce competitors, but at the same time, they have common problems that they want to solve together. So that could be, for instance, in optimizing flight traffic control, or it could be like in optimizing traffic flows through an airport, or it could be optimizing flows through an airspace, for instance.
Yeah.
And that requires collaboration between many different parties. And another part of this is also like specific to the airline industry in some senses, but it's also general, and that is that this industry wants to go to a future that is more automated. And I think that's, I mean, that's really something that is quite kind of common across many industries. You know that, I mean, if we want to increase our margins like a little bit, like the path to get there is to try to automate some steps of our processes a little bit. And one of the most common ways to automate anything today, that's with machine learning. So that's really where everything ties together. I think that enabling machine learning, like for new problems, that's what these kinds of organizations are looking at.
Mm-hmm. So it sounds like machine learning is already adding a lot of value by allowing people to extract more from what they have today, kind of extracting the value of the data that they live on, and also collaborating with that data. But it sounds like most frontier technologies, right? We deal with a lot in the IoT space, and blockchain is a kind of new entrant that not only allows you to do more, but it also allows you to also, collaborate more effectively across people that you don't necessarily trust, right? So I'm really excited to dive into how exactly blockchain and machine learning fit in today. But let's take a step back for now, right? A lot of people, again, have a very cursory service level understanding of what machine learning is today. How would you explain it to someone that's 5 years old about what machine learning is?
Yeah, so I think most important, machine learning, that is about it's about learning from data, and that's all there is, right? And I mean, today data is considered the most valuable asset that we have. But the big problem then is, okay, how do we extract value out of this asset? So yeah, we can, mining is a metaphor, and you could use that actually. So we can mine data for value. And the way to do that is usually with machine learning. And machine learning is really the tool of choice, because that's the only way to do that at scale. Right? Other methods, if that's analysis, for instance, or I mean, you can do like big data analytics, but it usually that requires more input from a human, from an analyst, to look at this. And machine learning also requires input from someone. You have to build machine learning models, but it is really, I mean, building these models, it is ways for us to look at really larger and larger data sets and extract value out of those data sets.
One thing I found really interesting about machine learning, I think you actually taught me this, is that every time someone signs into one of those websites and does a CAPTCHA, like, pick 3 images that have a traffic light in it, and you select 3, you're actually contributing to a machine learning model. So those are kind of, sneaky ways for big tech to train their machine learning models. And that's part of the manual input you described, right?
Yeah. When you have data in, I mean, you have to make sense of all of that data. So what you're describing now is it's typically called annotation, and that is taking raw unstructured data. But I mean, when you're looking at that, you have to know, okay, so what are we looking at? What are we training for? And that's a really good example of using a human to do that choice. So that specifically also that area, which is machine vision or computer vision, it's also an area that has been done quite large steps or really remarkable improvements over the last couple of years. And we all know that from face recognition tools being better and better. So, which is sometimes really good. I mean, you can just look in your phone, find all of your photos of myself or of my kids, or but at the same time, it's also, I mean, that has implications because someone else can use that technology to sort of find you in a big crowd, or when you're entering a store, and they know how you, I mean, can keep track of individual customers and what they're looking at in the store and so on.
Maybe talk to us a little bit about like the degrees of or the sophistication of different machine learning models, right? What we're talking about seems very advanced, right? Like taking one image and assessing, thousands and thousands of pictures of cats, so that you can understand which one of these are cats and which ones are dogs and which ones are, food items and random things, right? Then there's also the very, very sophisticated spectrum that people may be familiar with today is like Tesla vehicles, right? All these vehicles are driving and looking and learning at the same time to train future cars to drive better, right? But at the even basic levels of just simple bits of data that, we could be, normal people could have on their cell phones every day, what do the very, very basic machine learning models look like? It's not always going to be so complex, right?
No, absolutely. Yeah. And it gets much more simpler than that. On one side of the spectrum, it could be like a mean value. That is one kind of machine learning model. So it could be a statistical model. And it would be very, very simple to build a model like that. And every time you feed it with new data, it changes just a little bit. But when you're using that model, it doesn't really tell you that much. I mean, because when you're using a machine learning model, you typically send in some data and then you get prediction out. So how do we classify this data? So either you get a prediction out for a value, or you get a prediction out for a class. So is this a dog or is it a cat? If you have a mean value model, I mean, you will always basically get one value out. That's the mean. So it's not very useful. But going from that to the Tesla car, I mean, that it is a huge span. But most machine learning models out there are, I wouldn't say that they are like image-based, that very, very complex. But they are actually quite simple. They are more often dealing with numbers or categories, or so it's like text-based or number-based input, and you get a text-based or number-based output. So it can be, I mean, many times you have maybe like 5 or 10 different categories or labels that you're training with, and that could be enough. I mean, you can build a small, simple model with that.
Right.
And then you can get into much more complex systems with hundreds or thousands, or in the case of images and video, basically what you have is sometimes hundreds of thousands of different categories or labels.
Yeah, so I think that's a great summarization of like the end-to-end flow, right? Data in, model training, and some type of prediction, whether it's a class or a number that's out, right? Talk to us a little bit about the stakeholders involved in each one of those steps, right? So you mentioned multi-stakeholder processes, many data inputs. Are there also many data model producers and also, of course, users of the output?
Yeah. So, but what is interesting today is most of the time this whole process is basically like it's internal to one user. So it's usually one user that does the whole process today, and then you have on one side you have the data side. Today you typically have like it's most often companies, but also sometimes organizations that are collecting all the data that you want to use for training. You have some open data sets. That's good, but there is not that much like crowdfunding or crowd-based data that is generated, because it is hard to engage a community or a group of people to participate and contribute with their data, because it's very unclear what you get out. So that reCAPTCHA is one example where you're basically tricked to contribute to someone else's model, but it doesn't really give you anything. Yeah.
Right. So regardless of whether it's a large corporation or a small corporation kind of developing some models, it seems like they follow the same theme, right? They're kind of centralized in a way where the model builders and the data providers into those models are one and the same person, right? And then that becomes a kind of a centralization problem. You can see how, Google being the ones that put data into their models and being the ones that train their models at the same time, they've been in the news for a lot of bias against facial recognition against the minorities. And that's maybe where some of this stems from, right? So a more democratized way to put data in that represents a larger footprint of the world can make these models more smart and more fair, right?
Yeah, absolutely. But I mean, and it's also about capturing markets that are maybe underserved because it's not really a big market today. So you can also, I mean, you have the core markets for these big corporations, and it's totally understandable also that maybe like you're focusing on building. But I think that we really have a like long tail of potential machine learning models that it's maybe not feasible and it's maybe not economical today for these big companies to create models for that. But I do think that for others it really might be, because if you have like your core market is somewhere else, it might be worthwhile to in some cases you can take one of these big models and you can tune it for like your target audience, and then you enable a new kind of model. But like you say, it needs more data that is representative of what you're trying to achieve. And that's also, I mean, the challenge there is, okay, how do we get this data? And many times maybe it's not one entity that has all of that data, so you have to enable collaboration in some form.
Right. I mean, when you said that, it just made me, it reminded me of all these like frameworks people tell you to evaluate companies, right? And one of them is customer acquisition cost, CAC, right? And this almost seems like data acquisition cost for these very rare pieces of data that are, aren't, the common person. You're kind of searching for anomalies to put into your data set. Because if you only have the status quo representing what you're training your machine learning on, you're going to get a status quo prediction, but it's going to completely neglect all those anomalies out there, right? So even this gives a lot of opportunity for people that know that they're unique. And this might be their, empowering kind of a step in order to, participate in economies that they feel represent what they're talking about.
Yeah, absolutely. And I also think that I mean, in order to enable collaboration of also like more fringe cases or like use cases that are maybe not that big also on a global scale, that when you can have this approach where you basically go top down, you create these big models that are serving a really big market, but there are so many other use cases that is serving like a small niche market. But you have to find ways also then to really incentivize maybe, but at least enable people to gather around specific use case and find those that have the data that would make sense to train one of these models.
I think, we've been talking over the past few weeks about a lot of really amazing concepts just around this concept of permissionless access and kind of this bottoms up view of how to build a machine learning data set and a machine learning model, where even the people that contribute to that model, being an anomaly or being a status quo person, can be a fractional owner in that model, right? It's a very decentralized concept. It's kind of similar to some of these community-owned digital asset projects, even NFTs or other digital assets that are being fractionally shared today, right? So maybe talk to us a little bit about, we have a good understanding of what machine learning is and some of the problems in kind of centralization in machine learning. Maybe talk to us a little bit about how you see blockchain as a solution to some of these problems.
Yeah, so we have really two sides of this in this space. Like we have data in and then we have predictions out. And so if we start maybe on the data inside, one of the reasons why many of these models are also like they're created by centralized entities is that you need to trust all the data that goes into training. You need to also many times have full control over the data. You need to know how it's collected, how it's normalized, how it's pre-processed, like all of those things. But what we are able to do with blockchain, if we take it on the data inside, and especially why we're looking now at IoTeX and why we're collaborating, is that with a platform like IoTeX, we can validate or verify the data that comes in. So even if data is collected from many different entities of people, if there's a standardized way and we know how this data is formatted, how it's normalized, how it's collected, then we can still trust the data. So it means that if I have data and it looks like this, and this is this much data, you should be able to trust me and knowing that, yeah, that data is really a good complement to my data. And if we contribute this together, we have basically an equal part in making the model that we're training better. So I think that this is really one of the more interesting parts, that we can sort of scale the funnel of data that comes in. Now we don't need full control over the entire data acquisition funnel, if you like.
It's definitely filling two multiple thresholds, right? One of volume and the other of kind of verifiability, right? That's kind of the magic quadrant there. If you can source, say that I'm a company that is existing today and I have a data set, it's not only important to find data sets that are similar in the model and the interpretation of what this data means, but also, finding more and more of that in order to train something that's going to be statistically significant, right?
Yeah. So, and what we can do now is also look at the other side. I mean, so now we have a model, and once we have a fully trained model and we want to put that in production and use today, that's also basically something mostly done like within one company, and that is for some few different reasons. But we can take one of the main reasons is that when you have a final model, basically all the value is in that model. So you don't really want to hand over your model to someone else. Like you want to stay and have full control over your model. One of the things that you can do is you can create a model, you can deploy it somewhere, and you can give access to that model in form of API, for instance, and people will buy access to that. Basically, you could license it in a way that each invocation of this model, like you pay like a microcent for it or whatever it might be. But there is a problem with this as well, because then the person that, or the company that is using a model, then they are like fully dependent on the model provider, that the service stays as it is, price doesn't change. I mean, if I'm integrating this in my service, I would like to have full control and know, okay, what will happen in the future with this model? Will it stay like this? Will the price be the same? Will it be available? Will it upgrade? Will it change performance? Right? And so, I mean, you have a little bit of a trust issue here. And this, again, comes back to what can we do with blockchains? I mean, we can often increase trust in systems. I mean, trust goes both ways. So as a model producer, I don't want to hand over my model to someone else, because that would just be like giving away the full value. But also as a model user, I want to know, and I want to be able to predict in the future, do I have access to this model? What will that cost me? And how can I ensure that someone else doesn't like pull it away from me without me knowing, or without me being able to find a replacement? Yeah, it is the beauty of being able to put this in sort of a blockchain context, because if you can manage or govern access to this model using smart contracts, and that's really one of the also potential and possibilities that will be really, really interesting to explore more, like over the next months and years.
Definitely, on both sides of that, right? I think the data in and the data out, you put that very eloquently, right? Those are different types of stakeholders, but in future they could be the same stakeholder because of the way you design incentives, right? If you want the users of your model to be also contributors to like close the loop in some kind of virtuous cycle, that's definitely possible, right? But even without that, I think, with blockchain, you can really address this bottoms up data in part to make sure that people that contribute data that they own can also be fractional owners in the future cash flows of that data out model, right? Talk to us a little bit about that. Like, how big is the machine learning model industry, and like, what's the cut of the pie that people can try to participate in from here on out?
Yeah, I mean, it is. I mean, machine learning in itself, and I mean, this is $1 trillion market. It's maybe one of the biggest markets there is. But I mean, so the thing will be to like start to like break down and enable new use cases. I think that's all about it. So basically, the possibilities in this market is endless. But it is, I think that most of the value is looking at, for instance, like Spotify. So what did they do? They really enable the long tail of music. It's the same thing, I think, that like blockchain protocols will be able to do here, because I mean, you're able to create models, but I mean, the other part of that is also enable discoverability of models. So I mean, and this goes also from both sides. So if I have a device that can generate data, if it's possible to automatically find out, so where can I contribute this data and get some kind of reimbursement or get compensation back for providing this data. I mean, if I should like try to browse the web and somehow like scroll through thousands and thousands of models, that's not really feasible. But I mean, if I'm generating data according to some standardized schema, then someone else will be able to check that automatically and say, okay, where can I contribute? So that's like one really interesting potential way to increase sort of the way we handle data in, and same way on the other side. So I think that we will see in the future, and that with that I mean coming years now, is both like on the protocol level, but also on the front end level, finding some protocol based ways to discover and enable machine learning models, but then also like front ends where they're more specific. So maybe there will be some specific portals for finding agriculture-based machine learning models. So it's really focused. I think like we'll be able to find like more and more fine-grained areas, just like there were portals for like commercial portals for selling stuff in the old days of the web, but we will get there eventually with machine learning as well.
Yeah, I think that's really solved an interesting trend or an issue in one of the big trends in blockchain, which is data marketplaces, right? We talk a lot about data marketplaces today, but what's absent from that discussion is the verifiability of the data that flows through those marketplaces, right? I think that a lot of people think about the value of their data as a fiat number, right? It's like, how much is my data worth today? If you guys look that up on the internet, you're going to be sadly surprised that it's not worth that much today, because it doesn't fit into like the big machine learning models of a Google or Facebook or Apple that's kind of mining that data to extract the value from it, right? But if we democratize access to these machine learning models that do the work of extracting the value from your data for you, then it opens up a large marketplace where people can actually start to see some value in their data, right?
Yeah.
What do you think of that overall? It's kind of this the value of data today.
It's totally true. Yeah, and I fully agree with you. When it comes to general data marketplaces and these big models, so I mean they are good. They're solving problems, but those are really general. And for me, it doesn't really solve anything for me specifically. But if there is one model that really can influence like a big decision in my life, let's take one example. Maybe it would be possible to have a really fine-grained ability to see, okay, what are the pollution levels at that intersection where I'm looking at to buy a new apartment. And I mean, if there is a model that can predict that and give a really good map over prediction levels on a really local level in a town, that could like really make it or break it if I'm moving to that apartment or another apartment. So for me, I would pay, like I could pay tens, maybe hundreds of dollars of having access to that like once, because that's a really life-changing decision. So, and I think also those then that have been part in developing that model. I mean, if we like take this and develop this thought a little bit about like those that are participating in training model, maybe not only get reimbursed for it, but you might get reimbursed in having sort of a share of that model instead, and you get paid also for the license costs that goes in for those that are using the model. That could be like a really high value model for some people. So
it's like equity in the model. You're a shareholder in the model.
I mean, yeah, that's absolutely something that is doable and thinkable, and I think that will be something that is we will see that being developed. I mean, that's one of the goals that we have over the next couple of months, really, to develop that as a concept as well. So
I think it'll be a really big light bulb moment once people start to realize, like, especially for small to medium businesses, right, where they don't have infinite cash flows and things like that. Once they start to realize that the data that they sit on today, maybe some of them have not been extracted by IoT devices or by machine learning models, but take like any retail store, for example, right? The retail store has information on how many people walk in and walk out at certain times of the day, what types of garments are tried on every step of the throughout different hours of the day, and even like foot traffic outside of their properties. You know, consider like any kind of street with retail stores in it. Like these are all things that maybe don't seem like they have value, but anybody that's buying some real estate on that street is going to want to have that model or the machine learning model to know how many people walk by and what is the actual foot traffic, right? We always get these summarized scores about like walking scores or things like that, but having real people on the ground with verifiable devices to show you that, you know, this is the real truth, that has a lot of significance, especially for people that are looking for ways to kind of monetize the value of their businesses, right?
Yeah, absolutely. You can also think about like one step further. It's also like if you with your business, but you don't really have the customer flow to build models yourself or get really good statistics. But if you collaborate like with your neighbors that are maybe like running other kinds of small shops, but still together you can together find out, so what are the traffic flows or like the patterns of customers coming in across the days, across weeks, like different times of day, and how you're gonna man staff like in your shop, or like also maybe plan purchases or like and predict sales and everything. I mean, these things are maybe not possible to do today, but if you collaborate like with your neighbors, maybe they are. And so that is the same kind of, it's like it goes from 0 to 1, and you enable a completely new really use case.
Another way to think about it for me is kind of like, you know, I before COVID happened, right, I used to drive about an hour every day to work, and I would drive the same exact route, right, and I would use Waze, which is kind of like it has a very crowdsourced, decentralized feel to it, because anyone can add like, oh, here's a police officer, here's a pothole, here's this and that. But what you don't know is behind the scenes, Waze is gathering all of that data and making their own machine learning models and extracting the value from the data that you are providing to them, right? So even like a crowdsourced bottoms up version of Waze, where the people that are taking the time to, you know, stop driving and place a pin on something, they should get some kickback for that, whether it's in cryptocurrency or in equity of that model going forward, right?
Sure,
even if it's a tiny amount would make all the difference for you.
No, yeah, absolutely. And I mean, it also, I mean, when you are able to do that, if you're just getting something, I mean, the level of engagement you get back, I think that's also like really important. So everything that you can crowdfund, I mean, if you just feel part of something, that's usually maybe a bigger driver than the monetary compensation in itself. But I mean, just getting whatever, if you're getting badges or like the social recognition of being part of and contributing, is also something that is really valuable. And but doing this in this way, I mean, now we know you can contribute. What you do really has an effect. It matters, and you are part of like, or could be part of owning the result.
Mhm.
So yeah, I think that opens up many new possibilities.
Definitely. I think this concept is already starting to be proven as something extremely valuable just through other types of,
Mm.
crowd-funded and crowdsourced digital models. But the thing that's going to bring it, in my opinion, from concept to, global adoption and, viability is two things that you mentioned earlier on this call: verifiability and the privacy preserving nature of
Mm.
doing these things. So, piggybacking on top of this discussion we're already having about the overall concept of, data in, data out, and kind of decentralizing it and making it more community owned, where does verifiability and privacy preservingness kind of play in the future of this concept?
Yeah. No, okay. So I think we really excited. We've talked quite a lot about verifiability, but just because what we can do with verifiability is really that enables us to trust others, so we can collaborate. I mean, that's usually important. If we go to like privacy preservation, that is also sort of an enabler for collaboration, because there are lots of other data that today we're not really willing to share data. There's so much data that we don't want to share with others. So even if I have my shop, my store, maybe I'm not willing to share with the other neighbors around me what I'm selling, how much I'm making, what my margins are.
Mhm.
So all of that information would be really valuable for everyone to use, but if shared directly with others, that's not really feasible. I mean, you would be giving up so much, and someone else would be opening up like a store next door, undercutting your prices and taking all the business away. So like basically we usually say that we have three types of problems with data that we cannot share. So we have data that we don't want to share. That's the sensitive business data. But and then we have data that we're not allowed to share. So like regulated data, healthcare data, personal data. In Europe, we have GDPR legislation. It's a huge problem because basically you cannot do anything with data that contains personal information. And then we have like a third category of data that we have data that we cannot share, mostly for practical reasons, that either have really large data sets, or we have IoT data that is like we're generating much more data than these devices are able to push forward or maybe store centrally. So if we go back to the autonomous car examples, that most of these cars, like it's not feasible to see a future where all the data that's generated in cars are uploaded to some cloud somewhere. It's just way too much data that it's not possible to deal with it. So you have to use that data much closer to where it's generated. So that could be in cars, for instance. Now we have really powerful computers in cars. So we can take these models, we can train and tune these models like in the car themselves, or we have something called edge data centers. So data centers that are like distributed geographically and are situated closer to the devices that are generating all of this data. But in all of this, with all of these three types of data, we have the problem that we can generate data. That data could be good, normalized, we have good structure in it, we know how it looks like, but still we don't want to share it with anyone else. But in order to get value out of it, I mean, now we know that machine learning is a good way to get value out of data. So I can train a small machine learning model, but someone else can do that. Now I have two different machine learning models. Maybe they're useful, maybe not. So this is where privacy preserving machine learning comes in. So, and there are a number of different tools and methods that are being developed now, basically as we speak. So we've chosen to focus on one of these methods that can be used for privacy preservation, and that's called federated learning. Basically what we do is, instead of collecting all the data to one place and train one big machine learning model, we sort of switch it around. So we distribute the training of these models out to where the data is. So we train many different machine learning models, and then we aggregate the models back together. And that in itself is not a guarantee for privacy preservation, but depending on the data, depending on the model, and depending on some other tools used, you can achieve guarantees for like privacy preservation of the information that was in the data from the beginning.
Absolutely.
So,
I think
but what it does really, it opens up enables us to work on sensitive data basically, and train machine learning models on sensitive data.
Yeah, absolutely. And I think it's such an interesting journey to go down, right? Starting with, there's a lot of characteristics about what the future machine learning model will look like, right? We talked about three major ones: verifiability, community owned, and privacy preserving, right? And I think, we're really excited to welcome both the Scale Out and IoTeX communities to join in at the ground level with this kind of concept of the first community-owned machine learning model. Maybe call it, initial machine offering or initial model offering, right? And I think, that's really what blockchain is about, right? Getting people that are like-minded, that have similar things, and they want to collectively put them together. Even before we start talking about the enterprise landscape with letting competitors collaborate together, it's much easier to find like-minded people that want to share this concept. Maybe share a little bit about your thoughts with that. If you wanted to ask new community members to join us on this journey, what would you say to them?
No, yeah, exactly. So that's what I think. That's a really interesting potential that we have also, because I mean what we're doing now is this is the frontier of machine learning to a very large extent. And I mean the way that we're enabling this is not only pushing this from the top down. Like we need to collaborate, because I mean we from being able to collect data to really figure out, so what are the use cases that we want to enable with using this data that we have. I mean, I mean, I certainly don't know like what is most important for people, and you don't probably, you know a lot, and you know other things than me, what would be like really useful. But I mean, together we know more than than us individually. So, and I think that's just the starting point. But so getting together and collaborating, that is, I mean, there's enormous potential in doing that. So and what we want to see is like we said so many times now, like from the start of collecting data to like building the final model, that is sort of more, we want to see co-owned models that is generated by the community and co-owned, and it will be really interesting to see where that can take us.
Absolutely. So, it's a call to action to those that are watching right now. Whether you are a model builder and want to, find new data ins or data outs for your model, or you want to be a data contributor, right? We really encourage everyone to go and back the Pebble Tracker on CrowdSupply. And it's really going to be the gateway to, the first kind of data mining related use cases, where by owning a Pebble Tracker, you can be a contributor to one of those initial machine offerings or initial model offerings, and be the first stakeholder in kind of the community owned initial model offering from IoTeX and from Scale Out. So so much opportunity in the future. Yeah.
Yeah, exactly. So, and we're working hard on this right now. So we think that in May we will probably have sort of the first framework enabled to collaborate on data collection across like now blockchains. So we're bridging IoTeX platform with all the tools needed to go like end to end for building machine learning model, but then also serving that model back to the blockchain. And we're also enabling use of these machine learning models like on the blockchain. So we can have smart contracts invoke a machine learning model, get results back on blockchain. So like really bridging blockchain and blockchain with smart contracts and machine learning models. That's what we're hard at work like doing right now.
Definitely. I think we gave a perfect introduction into blockchain machine learning this time. Next time, we'll be sure to jump into kind of discoverability and invocation of machine learning models via blockchain. I think that's a level 2 level of comprehension. But Daniel, thank you so much for taking the time and really giving us a lowdown on everything machine learning related. You gave us a really wide view of the landscape, the issues that machine learning has, and the potential that it has, and what blockchain can do to help. But is there anything else that you want to leave with our audience with?
I think we covered a lot this time, and let's dig a little bit deeper next time. And if anyone has any kind of questions, like find me on Twitter, I'm Daniel Zack, or LinkedIn, whatever you want to use. And I'm always like interested to talk about machine learning in any shape or form. But it was like a pleasure to be here and talk to you also today.
Absolutely. So if anyone is interested in contributing to this project, as Daniel and I mentioned, this is all about bottoms up, right? We want the community to be involved. Anyone that's interested in being a model builder or a data contributor or a model user, get in contact with Daniel and myself, and we'll be happy to welcome you into this amazing project. But until then, Daniel, thanks so much for taking the time, and we'll be sure to be in touch very soon.
Yeah, thank you so much.